Okay, hi guys. Of course, this is the final video for CCNA4, and so we're looking at the a practical test. So, as you can see on the screen, we have a network, and so we have a LAN hanging off of this router branch 1, and so there's 4 hosts. No big surprise. And of course, it's got a WAN link to the ISP, and then branch 2 also has a WAN link to the ISP, and then of course branch 2 has its own LAN as well. Now, if we look at the routers themselves, they don't have any extra routing information. They've just got their directly connected networks in their routing table. That's it. So if we do show IP route, it just knows the directly connected networks. So 192.168.10.0, that's the LAN, and then there's 199.99.99.0 for the WAN link. And so on the ISP, not a greatly different situation here either. So EN show IP route, and this has just got the 2 directly connected WAN links. And so branch 2, again, not greatly different. Come on, there we go. EN show IP route. So again, just your directly connected network. So the LAN and the WAN. All right, so we've got some requirements here on the screen. So basically, we need to configure all the routers to use PPP as their WAN protocol, and CHAP, or of course Challenge Handshake Authentication Protocol. And so these WAN links are in their default settings at the moment, and so they're using HDLC. And so of course PPP is standards based, and of course the authentication is another advantage it has on it. And then we're going to set up a GRE tunnel between branch 1 and branch 2. So it'll go through the ISP, but they'll just be, of course, double encapsulated packets that the ISP won't really know the contents of. And so we'll set up a tunnel so that we can then set up OSPF to run through that tunnel between branch 1 and branch 2. And so the ISP, that's not going to get any extra information about. So, when we looked at its routing table, the ISP did not know how to find this LAN or this LAN. So this tunnel will be enough where the routers can exchange information using OSPF, and they will actually be able to route packets through the tunnel. And so after that, then there's a couple of ACL requirements that we need to put in as well. So I'll talk about them a bit later. So let's have a look at a config I've prepared. And so of course, because we're using CHAP, we need to create some user accounts. And so of course you create the user account with the same user name as the host name of the routers. And then of course we just use the password. And so branch 1, branch 2 and ISP. And so of course that authentication is going to go in both directions for both of them. Now, I've got a default route which branch 1 and branch 2 can use, just because branch 1 needs to be able to find this interface on branch 2, and branch 2 needs to be able to find this interface on branch 1. I could have done an IP route and just done the destination network here for branch 1, and for branch 2 I could have done the destination network here. That would have worked, but now I've done the default route just because it'll work on both devices. And so then, of course, for the serial interfaces, you need to put encapsulation PPP in there to get PPP running. And then, of course, to get CHAP running for authentication, you use this command, PPP authentication CHAP. And so that combined with the user accounts will be enough for that to work. All right, let's have a look at the tunneling. And so we need to, of course, create a virtual interface tunnel 0. And then within that, you need to configure what kind of tunnel it will be. And so it's going to be a GRE tunnel and set up to use IP. course, we need to set an IP address. I've been very imaginative. I've used 10.0.0.1. And so then, of course, you need to tell it where the tunnel starts and where it finishes. So, of course, the tunnel source is S010, which, of course, is this interface here. And the tunnel destination is this IP address, of course, which is the interface on the other end. And so that's its IP address. So, of course, for branch 2, the tunnel configuration, of course, needs to be reversed. And so, again, it's tunnel 0, it's GRE for IP, 10.0.0.2, of course, for the IP address. And so the source, of course, is still the local interface, and the tunnel destination is 199.99.99.1, which, of course, gets it to that interface. So that's enough to create the tunnel. And, yeah, because they've got this default route, they'll be able to get to the other end. And so from here, and then, of course, we need to set up OSPF to use the tunnel. And so we need to, of course, have a network entry for the LAN. And so, of course, this is what will be used on branch 1. This one would be used on branch 2. And this one, of course, would be used on both 1 and 2, because that's the network that joins them together. That is actually enough to get full connectivity on the devices. So let's get configuring, eh? All right, so yeah, I normally have video, but for some reason they didn't want to turn on today. So let's open up branch 1. Could have sworn I just minimized it, but anyway. And so what do we need on branch 1? So yeah, might as well put all 3 usernames in, can't hurt. IP route it needs, and of course that's the serial interface it needs. So we'll do that. Have a look. I don't see any errors. There's a warning, but because it's a point-to-point link, that warning is not particularly important. And so now we're into interface serial mode there. And so, of course, we need the encapsulation and the authentication commands. This is branch 1, so it needs these commands as well. And so we can see the encapsulation PPP. Still, again, no errors that I can see. Of course, the serial interface did go down because the encapsulation on branch 1's end is PPP, on the other end it's still HDLC. So until I do both ends, it's going to go down. But the tunnel interface is up because it's a virtual interface. All right, so now we need to get router OSPF running. It needs the 10 network. And it needs, sorry, 192.168.10, as well as the 10 network, sorry. Copy, paste. So that's pretty much branch 1 finished. All right, might as well look at the ISP router. Now we don't need the default route. That would actually ruin things. But we do need some user accounts. We need both interfaces on this device. Okay, so that's the other end, and so that interface has gone up again. So this is the second interface that points to branch 2. So of course this will take the interface down because it's got PPP on one end and not the other. Okay, we don't need the tunnel. We don't need the OSPF. Just an end and a copy run start should be all that's required. Okay. So that's the ISP. Now branch 2. So back to the top. So that's working. We need this encapsulation. That should be the last interface up. Yes. Of course, we need branch 2 stuff. We need to start OSPF. And then we need the last 2 network commands and a copy run start. So a couple of things should happen when I put this in. The interface is already up. We should also get OSPF forming an adjacency. Have a look at that. Let's do a show IP route now. So a couple of things should have changed. One of which is we've now created that 10 network interface for the tunnel 0. We've also learnt through OSPF 192.168.10.0. So that's good. We've got the default route as well. And of course, we've got 2 directly connected networks, which is what we had anyway. All right, now, so let's try pinging from this host. So this is 10.2. Let's ping 22. Ping 192.168.20.2. ARP request or 2 getting about, and then we have success. So even though the ISP does not have any real extra information, if you do show IP route, still only knows it's 2 directly connected networks. That's all it knows. And so, yeah, that is it. Because it's triple P, you actually get an extra entry. You actually get a connection for the other end of the cable. But that's about it. And so we only know about the 2 serial links, and that is it. But still, they're able to route from one to the other, because even though this pinged that host, it got encapsulated inside of a tunnel one, which was sent to that host and then decapsulated and then went on. So it's all very hidden to the hosts. Here is a proper name for it, and it slipped out of my head. So let's try the other way. 192.168.20. Oops, that's who it is. I need to ping 10, don't I? .10. Ah, it's 10.2, dork. And so works in both ways. Now, the reason I've done that is because we're going to do some access control lists that are going to change that. Now, one thing I might do is I might actually put in a DNS server, because that host down the bottom is a DNS server. So 192.168.20.10 is the DNS server. So let's try that. So if I ping www.cisco.com, there should be a DNS request, and then it should ping away. Did I get the address right? Yeah, the DNS took a little while, but have a look at that, it worked. So I've also got a host entry for branch 1 and also branch 2. So that's DNS working nicely. So of course branch 1 and branch 2 are the routers. So if you want, we can have a look at the server. It is got DNS and it's got those 3 entries in it. So of course they're the router IP addresses, and that's the servers. Suppose one thing we need to also, one of the access control lists actually tells us to block the web server. So www.cisco.com. And so we get a web page. So we've got pretty good functionality here now. Now, we've got some, we've got some things we need to change. Now, we need to create an extended named IPv4 ACL to permit branch 1 LAN clients access to the DNS server located in branch 2, but deny access to the web server on the same server. All other traffic is allowed. So how have I done that? So I've got an access list here. And so it's our IP access list extended DNS. So I had to give it a name to permit the DNS server. Now, it basically tells us to permit DNS, block web access, but all other traffic. So basically, all I really need to do is block out web access and permit anything else. So here I've got deny, TCP, and so source addresses of that LAN, so 192.168.10.0, and then to access the host with port 80. So the server host, we're going to block anything that's got a destination port of 80. And then permit IP any. So of course that will match all other traffic. Now, because it's an extended ACL, I'm going to put it inbound on G00. And so interface G00 inbound, and so it's IP access group DNS, which of course is that, and inbound. So that's how we'll apply that. So we'll test that a little bit later once we've applied it. Now there's another ACL requirement here. So we create an extended numbered ACL on branch 1 that does not allow pings started from outside, but it allows ping replies to return. So basically, of course, when you ping, let's just say this host was pinging, like I did test it before, it sends an echo request through to that host, and then this replies with an echo reply. So of course, to stop the pings started from outside, we need to block that echo request. But of course, if now we're going to allow all other pings to return, and so if I ping echo request, that's got to be able to get out, but we've got to let the echo reply back in. So we've got to figure out an ACL that will do that. So it's again not particularly complex, but anyway, so it's a 2-line ACL, and so I'm going to deny. So access list 100 deny. Now the protocol is ICMP, Internet Control Message Protocol. Any source, any destination, but with a destination, well, the type of packet, the type of ICMP packet is an echo. And so they don't actually have a definition for echo request. It's either echo or echo reply. And so basically we're stopping echo, which is an echo request. And then the next line is permit IP any. Now, this is a bit of a strange one for my demo. I actually had tried applying this originally to the tunnel interface, which would be the logical way to go. And yeah, that didn't work. So for some reason, it would not allow the IP access group command on the tunnel interface. So I've got to admit, I'm going to have to try this out on a real router at some stage or other. But yeah, on Packet Tracer at the very minimum, it would not allow me to do an IP access group command on the tunnel interface. I find that very hard to believe that that's the situation in real devices, but anyway. So I then tried it on the serial, and of course it just wasn't coming in through that interface, so it didn't apply. Didn't think it would. So I've had to actually put it again on G00 outbound. And so of course it's packets that have come into the router and then going out to the Ethernet. And so that's the way I've applied this particular line. And so we've already tested all the functionality. Everything works at the moment. Once I apply these access control lists, I should actually start blocking some stuff. So let's do that. So copy, we'll put it in branch 1 and paste. And so, as you can see, I don't see any error messages at all. All right, so let's have a look. So show run. So of course in G0, you've got DNS inbound and you've got access group 100 outbound. And then we've got the access list here. So of course this is how I defined it. So there's the one blocking web going to that particular host, but allowing all other traffic. So of course with 100, we're blocking those echoes coming into the network, and then but permitting all other IP traffic. So that should be right. So if you do show access lists, again, you can see that as it is, and of course you get the sequence numbers as well. But let's try out some stuff. So let's repeat some of those pings we did earlier. So let's ping cisco.com. So that's going. So it's going out there and it's coming back successfully. So that's good. Let's try branch 2 because, hey, it's out there. And that's working as well. Now, while we're sitting at this host, now, of course, you'll notice that DNS was working because, you know, I actually had that and it worked nicely. I had the host names as opposed to the IP addresses, and so that worked nicely. Now, let's try the web browser. This should not work. And so it worked earlier, www.cisco.com. And let's request timed out. So that actually blocked the web. Now let's have another look. Let's do that show access lists again. We should actually get some matches. And so that web page, it took 12 packets to be blocked before it actually gave up the ghost. And here the IP ANYs are for all those pings that went out and things like that. So coming back, none have matched this yet because I haven't actually pinged from the outside yet. But all the packets coming back in, all the others have actually been let through. So that's all pretty good at the moment. Let's now try to ping that other host. Of course, the ping worked before. Let's try it now. And we're actually getting destination host unreachable. And so 10.0.0.1, of course, is this router here. There's tunnel 0 interface, and so it's not allowing it to ping that host. So that's basically all good. Let's try it from this host as well, just because we can. Ping 192.168.10.2, all unreachable. So let's again look at this. The show access lists, and now we should have some matches for the ICMP line, and we do. So of course Windows does it 4 times, Cisco does it 5 times. That's why it's 9 matches. And so of course this is how you should always test your access control lists, is by putting it in and testing it. Maybe not want to do it on a live network, but anyway. So yeah, so that is basically all of the requirements now met for these. And so basically, yeah, job done. So next week, we're going to have the theory test, which will start at 1 as per normal. Through that Cisco WebEx session, and then at 2 o'clock roughly, it'll be time for the practical. So the theory test is 1 hour, the practical test is 2 hours, and so of course there will be a packet tracer activity like there has been for earlier in the year. Now there is actually a trial. Hoping the site is still open. There is another practice practical available for you. So under Files, Flinders Term 4, there is a Cisco 4 Practice Practical version 2. Of course, this is a PKA, so you get the network window plus you get the instructions as well. And so you can have another practice, and of course, that will be slightly different to the one I just did, but similar-ish. And so I will put a solution up on the site early next week, Monday or Tuesday next week, so you can actually see it. So I'll give you the weekend to try and get through it. So yeah, have a good week. Stay healthy, and yeah, next week's the assessment, and then that's the end of the year for Cisco. So have a nice weekend. I'll see you then. Goodbye.